November 7th, 1943, Caen Airfield, occupied France. Oberst Hans Trautloft stood beside the massive American fighter that had just rolled to a stop on German soil, and what he saw contradicted everything Luftwaffe intelligence had told him about enemy aircraft design philosophy. The machine before him was enormous, dwarfing every single engine fighter in the Reich's inventory. Its wings spanned 40 feet. Its fuselage stretched 36 feet from spinner to tail. The radial engine alone looked as large as some complete fighter aircraft. Most troubling of all, the American pilot who climbed down from the cockpit looked genuinely surprised to find himself in France rather than England. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Second Lieutenant William E. Roach had become disoriented during a bomber escort mission. His flight leader had been shot down over northern France, and in the confusion of combat and deteriorating weather, Roach had simply landed at what he thought was an English airfield. The Luftwaffe now possessed the first intact flyable P-47 Thunderbolt to fall into German hands, and the intelligence value of this single aircraft would prove more devastating to German morale than the loss of 100 Focke-Wulf fighters in combat. The Americans were building these machines by the thousands. That morning, Roach had been one pilot in a formation of over 100 Thunderbolts, escorting B-17 bombers deep into German-controlled airspace. The sheer scale of American fighter production suggested an industrial capacity that German planners had consistently underestimated throughout 1943. Every Luftwaffe pilot who encountered these massive American fighters returned with the same disturbing reports. The Thunderbolts could dive faster than anything in the sky. Their 850 caliber machine guns delivered devastating firepower, and most troublingly, they absorbed battle damage that would have destroyed a Focke-Wulf or Messerschmitt and simply kept flying. Within hours of Roach's capture, Luftwaffe ground crews swarmed over the P-47 designated Beetle by its American ground crew. The markings told its story through nose art and kill marks. Engineers photographed every system, measured every dimension, documented every technical feature before the fighter could be damaged or stripped by souvenir hunters. German recovery specialists immediately recognized they had captured something unprecedented, not just another enemy aircraft, but a complete example of American fighter technology that represented a fundamental challenge to Luftwaffe tactical doctrine. The bomber represented more than intelligence value. It symbolized American industrial philosophy made manifest in aluminum and steel. German fighters prioritized maneuverability and climb rate, accepting limitations in range and firepower to achieve superior dogfighting characteristics. This American machine reversed every priority. It sacrificed turning performance for speed, traded climb rate for high-altitude capability, accepted enormous size and weight to achieve devastating firepower and extraordinary range. The design philosophy suggested Americans understood modern air combat differently than German theorists, and 3 years of combat experience across 2 theaters suggested the American approach might be fundamentally correct. German mechanics carefully prepared Beetle for flight to Rechlin, the Luftwaffe's premier testing and evaluation center located approximately 50 miles north of Berlin in Mecklenburg. American national insignia disappeared beneath German markings. Large black crosses adorned wings and fuselage. A swastika marked the vertical stabilizer. The distinctive yellow identification colors of Luftwaffe test aircraft covered the cowling. 2 days after capture, on November 9, 1943, a hand-picked German ferry crew climbed aboard for the flight to Rechlin. The flight plan was distributed to every Luftwaffe fighter base and flak battery along the route with explicit instructions not to engage the captured Thunderbolt. Despite these precautions and the clear German markings, some Luftwaffe forces fired on their own prize, inflicting minor additional damage before recognition signals could be confirmed and the attackers called off. The incident highlighted German eagerness to destroy American fighters on sight, and the difficulty of coordinating operations across fractured command structures in a military organization, increasingly strained by fighting on multiple fronts. When Beetle touched down at Rechlin after its circuitous flight from France, it entered a world dedicated to understanding enemy technology. Rechlin served as the central testing facility for all Luftwaffe aircraft evaluation, the German equivalent to Wright Field in Ohio or the Fife Maratians FAUS, Royal Aircraft Establishment at Farnborough. Every captured Allied airplane that could be repaired to flying condition eventually made its way to this secretive base, where hundreds of technicians, engineers, test pilots, and support personnel dedicated themselves to the single mission of understanding how enemy aircraft worked and how to defeat them. For 3 weeks following its arrival in mid-November 1943, Beetle remained grounded while teams of specialists conducted exhaustive examination. Engineers removed panels to study structural design, marveling at the sophisticated construction that gave the P-47 its legendary toughness. They measured skin thickness, analyzed alloy composition, tested rivet patterns and welding techniques. Every system received detailed documentation that filled technical reports distributed across Luftwaffe commands. The electrical network with its miles of wiring revealed American approaches to aircraft systems integration far more sophisticated than German practice. The hydraulic controls showed valve designs and pressure regulation systems that simplified pilot workload. The oxygen distribution system demonstrated American understanding of high-altitude operations, where the air became too thin for human survival without supplemental oxygen. The intercom system provided clear communication despite engine noise. The fuel management system allowed pilots to shift fuel between tanks to maintain proper center of gravity during long missions. Each component was photographed from multiple angles, sketched in detailed technical drawings, measured with precision instruments, and compared to equivalent German systems. But the feature that commanded the most attention from Luftwaffe aeronautical engineers was the turbo supercharger installation. This system, unique among fighter aircraft of 1943, explained the P-47's exceptional high-altitude performance that gave American pilots a decisive advantage, where German fighters struggled. The supercharger system occupied the entire aft fuselage, a massive turbine driven by exhaust gases that compressed incoming air and forced it back into the engine at altitude where atmospheric pressure dropped too low for normal engine operation. The complexity was staggering. Exhaust from 18 cylinders flowed through separate pipes, running along each side of the cockpit to drive the turbo supercharger turbine at 21,300 revolutions per minute. The compressed air then passed through an intercooler to reduce temperature before entering the engine. At full power, the exhaust pipes glowed cherry red at their forward ends, and the entire system generated sufficient heat to warm the massive fighter, even at altitudes above 30,000 feet, where outside temperatures dropped to 50 degrees below zero. German engineers had attempted similar installations in experimental fighters, particularly the Focke-Wulf Fw-190s variant, but had abandoned the effort after the turbocharger system proved unreliable and added unacceptable weight and complexity. The Americans had solved these problems through sophisticated engineering and accepted the trade-offs. The P-47 was enormous, partly because the turbo's supercharger system demanded space. The fighter was heavy, partly because robust construction was needed to absorb the stresses. The Americans had designed an entire aircraft around high-altitude performance, accepting penalties in other areas to achieve dominance where it mattered most. Luftwaffe test pilot Hans-Werner Lerche, who would become the most experienced pilot of captured Allied aircraft during the war, first encountered the Thunderbolt in late November 1943. Lerche approached captured aircraft with scientific curiosity rather than ideological prejudice, a professional attitude that made him invaluable to the Luftwaffe's evaluation program. His engineering background from university studies combined with exceptional natural flying ability, developed through years of glider flying, made him ideally suited for the demanding work of test flying enemy aircraft without instruction manuals. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Training programs, or qualified instructors. When Lerche climbed into Beetle's cockpit for his first evaluation flight, he confronted an instrument panel that differed fundamentally from German practice in both arrangement and philosophy. American designers favored centralized panels with standardized gauge positions that remained consistent across different aircraft types, allowing pilots to transition between aircraft more easily. Circuit breakers replaced fuses in the electrical system. Hydraulic pressure indicators used different scales. The throttle quadrant operated with reversed logic compared to German aircraft, with forward motion increasing power rather than decreasing it. The cockpit itself stunned Lerche with its sheer volume. German fighters featured cramped cockpits where pilots sat hunched over controls with limited room for movement. The P-47 offered space approaching that of a medium bomber. A pilot could move freely, adjust position for comfort during long missions, and access controls without contorting. The Americans had prioritized pilot comfort and ergonomics in ways German designers never considered. Luftwaffe ace Adolf Galland, after flying a captured Thunderbolt, would later report that the cockpit was large enough to walk around in, a joke that contained uncomfortable truth about different national approaches to fighter design. Lerche spent hours in the cockpit studying controls and instruments, making educated guesses about function and operation, carefully testing assumptions at altitude where mistakes wouldn't prove immediately fatal. The instrument layout confused even his experienced eye. He gradually managed to ascertain the function of most levers and instruments, but obscure controls remained mysterious. The hydraulic flap system, for instance, included compensation mechanisms to ensure equal flap angle on both wings, but how this functioned wasn't immediately clear. Lerche decided to try the flaps at safe altitude, operating them step by step to understand their behavior under dynamic pressure. On December 1, 1943, Beetle finally took to German skies under Luftwaffe control with Lerche at the controls. The bomber handled smoothly despite its size, responding to control inputs with surprising docility. American pilots had consistently praised the P-47's flight characteristics in reports that German intelligence had intercepted or obtained through prisoner interrogations, and German test pilots quickly confirmed these assessments through direct experience. The Fortress flew with remarkable stability for such a large aircraft weighing 10,000 pounds empty and up to 17,000 pounds fully loaded. Control responses felt predictable and balanced across the entire flight envelope. The massive Pratt & Whitney R2 1800 double wasp engine, an 18-cylinder radial power plant, delivered smooth power throughout the operating range. Even during deliberate single-engine shutdowns to test emergency procedures, the aircraft maintained controllable flight, demonstrating the robust design that explained why damaged P-47 seconds regularly returned to England after sustaining battle damage that would have doomed lighter fighters. But the test that would prove most significant to German fighter tactics involved high-altitude performance evaluation. This was where the Thunderbolt's design philosophy revealed its true purpose. Lerche climbed to 30,000 feet, then continued upward. At 35,000 feet, where Focke-Wulf Fw-190s struggled for power and Messerschmitt Bf-109s approached their operational ceiling, the P-47 continued climbing effortlessly. The turbo-supercharger system maintained engine power at altitudes where German fighters became sluggish and unresponsive. At 40,000 feet, approaching the aircraft's service ceiling, Lerche had climbed higher than most Luftwaffe fighters could effectively operate. The Thunderbolt remained fully controllable. The engine delivered adequate power. The controls responded crisply. From this altitude, Lerche could see for over 200 miles in clear conditions, and any German fighter attempting to intercept would be fighting upward through thinner air, while the P-47 pilot held every advantage of altitude, speed, and position. The tactical implications were devastating for Luftwaffe planners who understood modern air combat. American bomber formations crossed into German airspace at altitudes between 25,000 and 30,000 feet, where their Norden bomb sites achieved maximum accuracy, and German anti-aircraft artillery became progressively less effective. Before the P-47 entered service in April 1943, German fighters could attack these formations from above, diving through defensive fire to make high-speed passes before climbing away. The Messerschmitt Bf-109 and Focke-Wulf Fw-190 both performed well at these altitudes when lightly loaded for interceptor missions. But now American fighter escorts operated 5,000 to 10,000 feet above the bomber formations, maintaining position where they held every tactical advantage. German fighters attempting to reach the bombers had to climb through a gauntlet of P-47 seconds that could dive on them from above at speeds exceeding 450 miles per hour. The Thunderbolt's exceptional dive performance, a consequence of its heavy weight and clean aerodynamics, allowed it to accelerate faster than any fighter in the Luftwaffe inventory. A P-47 pilot could dive from 40,000 feet, destroy or scatter German interceptors climbing toward the bombers, then zoom climb back to altitude using momentum from the dive. German pilots quickly learned through bitter experience that diving away from a Thunderbolt was futile. The American fighter would simply follow, accelerating faster, closing range rapidly, bringing 850 caliber machine guns to bear. The Focke-Wulf Fw-190, previously the Luftwaffe's most feared fighter, could not escape a Thunderbolt in a dive despite being lighter and more maneuverable. The Messerschmitt Bf-109, with its smaller size and inline engine, also failed to match the P-47's dive performance. This forced German pilots into turning engagements where the Fw-190 held advantages, but turning fights consumed time and fuel while burning energy that left fighters vulnerable to follow-on attacks by other American escorts. The Americans didn't need to outmaneuver German fighters in classic dogfighting. They simply needed to prevent German interceptors from reaching the bombers, and the P-47's combination of altitude advantage, dive performance, devastating firepower accomplished this mission despite being outturned by every German fighter in service. Over subsequent weeks throughout December 1943 and into January 1944, multiple German pilots flew Beetle in varied test profiles, designed to explore every aspect of the aircraft's performance and handling characteristics. High-altitude endurance tests measured fuel consumption and range at combat cruise settings. Engine synchronization evaluation revealed sophisticated propeller control systems, featuring constant-speed propellers and automated governors that reduced pilot workload while maintaining optimal engine performance across different flight regimes. Formation flying exercises demonstrated the P-47's stability in close proximity to other aircraft, explaining how Americans maintained those tight defensive formations that made coordinated attacks so difficult. But perhaps most impressive to Lerche and other German test pilots was the Tilus, aircraft's sheer robustness and damage tolerance. The P-47 absorbed punishment that would have destroyed equivalent German fighters, continuing to fly and fight after sustaining damage that seemed unsurvivable. Its structural strength came from heavy-gauge aluminum alloy frames and stressed skin construction that distributed loads efficiently across the entire airframe. Multiple redundant systems meant single failures rarely proved catastrophic. Self-sealing fuel tanks prevented fires from small-caliber hits. Armor plate protected critical crew positions and vital systems with particular attention to protecting the pilot, engine, and fuel system. The radial engine configuration provided inherent advantages over inline designs. Liquid-cooled engines like the Daimler-Benz DB600 series used in many German fighters required coolant systems with radiators, pumps, and plumbing vulnerable to battle damage. A single hit to the cooling system could cause engine failure within minutes, as temperatures climbed beyond safe limits. The P-47's air-cooled radial engine had no such vulnerability. Cylinders could be shot away without immediate catastrophic failure. The massive engine served almost as armor, shielding the pilot from frontal attacks. German armament specialists conducted firing tests to understand the P-47's vulnerability to various weapons. They discovered uncomfortable truths about German cannon effectiveness against American construction methods. The standard 20mm MG-151 cannon used throughout the Luftwaffe proved marginally effective against the Thunderbolt structure. A hit might damage systems or wound the pilot, but seldom achieved immediate catastrophic kills. The 30mm Mk-108 cannon, when hits were achieved, proved devastating, but the weapon's low muzzle velocity and limited ammunition capacity made it difficult to use effectively in high-speed combat. Meanwhile, reports from frontline Fw-190 units painted an increasingly troubling picture of combat encounters with American Thunderbolts. German pilots were dying, not because they lacked skill or courage, but because they faced an aircraft specifically designed to counter every tactic the Luftwaffe had developed through 4 years of combat experience. The Fw-190, introduced in 1941, had been revolutionary, a radial engine fighter that outperformed the Spitfire Mark V in nearly every metric except turning radius. Its 4 20mm cannons and 2 machine guns delivered devastating firepower. Its wide-track landing gear made it easy to handle on the ground. Its rugged construction allowed it to survive damage. But by late 1943, the Fw-190 was encountering an opponent designed specifically to exploit its weaknesses. The American P-47 weighed nearly twice as much as the Focke-Wulf, 8 tons versus 4 tons. It carried 8 heavy machine guns versus the Fw-190's mix of cannons and machine guns. Most critically, it operated comfortably at altitudes where the Fw-190's BMW 801 radial engine struggled for power. The BMW engine, while robust and reliable, lacked the sophisticated turbo supercharging of the American Pratt & Whitney. Above 25,000 feet, the Fw-190 lost power and responsiveness. The controls became heavier, the climb rate decreased dramatically. Roll rate, the Focke-Wulf's greatest advantage in combat, diminished as airspeed dropped. Meanwhile, the P-47 maintained full capability, its turbo supercharger ensuring the engine received adequate air pressure regardless of altitude. German pilots reported that engaging P-47 seconds above 25,000 feet was suicidal unless they held significant numerical advantage or could execute perfect surprise attacks from the sun. The Americans typically maintained position 5,000 feet or more above their bomber formations, giving them ample time to react to German interceptors. When P-47 seconds dove to engage, German pilots had seconds to decide whether to turn and fight, accepting inevitable energy disadvantage or attempt to dive away, accepting that the heavier American fighter would overtake them. Neither option offered good survival odds. Turning fights allowed the P-47 pilot to extend away using superior speed, then return with energy advantage for repeated attacks. Diving away simply delayed the inevitable as the Thunderbolt accelerated faster and caught up within seconds. German pilots learned that the only effective counter was to refuse combat entirely when P-47 seconds held altitude advantage. But refusing combat meant abandoning intercept missions and allowing American bombers to reach their targets unopposed. The data emerging from Rechlin confirmed what frontline reports had been suggesting since spring 1943. The P-47 Thunderbolt represented more than just another enemy fighter. It embodied a complete American philosophy of air combat that prioritized different qualities than German doctrine emphasized. Where German fighters traded weight for agility, American fighters accepted mass to achieve firepower. Where German designs optimized for short-range interception, American fighters incorporated fuel capacity for extended range. Where German engineering pursued technical perfection, American design embraced practical effectiveness. January 1944. Beetle underwent additional testing under the direction of Oberingenieur Otto Körner in Department E3 at Rechlin. Engine performance evaluation measured power output at various altitudes, documenting the Pratt & Whitney R2800's remarkable consistency across the operational envelope. Supercharger efficiency analysis determined optimal operating parameters for the complex turbo system. Fuel consumption mapping created charts showing range under different conditions, revealing that the P-47 could escort bombers to targets deep inside Germany and return to England, a capability that fundamentally altered the strategic bombing campaign's effectiveness. Each test session provided more evidence of sophisticated American engineering. The electric systems used circuit breakers instead of fuses, allowing pilots to reset tripped circuits in flight rather than replacing blown fuses. The hydraulic systems incorporated fail-safe features that prevented catastrophic failures. The oxygen system included automatic regulators that adjusted flow based on altitude. Every system demonstrated thoughtful design that anticipated failure modes and provided backup capabilities. But what truly disturbed German analysts was the manufacturing quality evident in every component. American aircraft demonstrated standardization and interchangeability that German industry had never achieved. Parts manufactured at different factories across the United States fit together perfectly during assembly with no hand-fitting required. Tolerances were tight and consistent. Surface finishes were smooth and professional. Assembly techniques showed systematic production methods rather than improvisation. The implications extended far beyond this single captured fighter. If American industry could manufacture such sophisticated aircraft with this level of quality control while producing them in thousands, what did that suggest about overall American industrial capacity? German intelligence analysts ran calculations based on known American factory locations and estimated production rates. The numbers seemed impossible, yet were confirmed through multiple sources, including prisoner interrogations, reconnaissance photographs of American airfields in England, and intercepts of American radio communications. Republic Aviation Corporation was producing approximately 28 P-47 Thunderbolts per day from two factories, one in Farmingdale, New York, and another in Evansville, Indiana. Additional production came from Curtiss-Wright Corporation. Monthly production exceeded 800 aircraft during peak periods in 1944. Annual production would ultimately exceed 4,000 fighters from a single aircraft type, while American factories simultaneously built thousands of P-51 Mustangs, P-38 Lightnings, and numerous other types. For comparison, total German fighter production across all types barely exceeded 3,000 aircraft monthly in early 1944, and this number included training aircraft and obsolescent types pressed back into service due to shortages. The Focke-Wulf factories managed approximately 250 Fw-190s monthly at peak production. Messerschmitt plants added similar numbers of Bf-109s. Other manufacturers contributed smaller quantities of specialized types. But the combined German fighter output couldn't match the production rate of a single American aircraft type. The arithmetic was brutal and inescapable. American factories were producing more fighters per month than Germany produced across an entire quarter. The United States was building more military aircraft in 3 months than Germany built in a year, and American production was accelerating while German output stagnated or declined due to Allied bombing, raw material shortages, and disrupted transportation networks. February 19, 1944. Beetle appeared at a major exhibition held at Rechlin for senior Luftwaffe commanders and technical specialists. Alongside the captured P-47 sat examples of other Allied aircraft that German forces had recovered through combat losses or forced landings. A P-51 Mustang demonstrated American long-range escort fighter development. A P-38 Lightning showed twin-engine fighter design approaches. Multiple Spitfire variants illustrated British fighter evolution through the war. A captured B-17 Flying Fortress represented American heavy bomber capabilities. The display served multiple purposes beyond simple aircraft recognition training. Senior officers walked slowly around the P-47, studying its construction, noting the massive engine, examining the wing structure, inspecting the landing gear. Oberst Johannes Steinhoff, a Luftwaffe ace with over 100 victories who commanded Jagdgeschwader 7, stood silently before the Thunderbolt for several minutes. He had encountered these fighters in combat over Germany. He had watched them dive from altitude to scatter his formations. He had lost pilots to their devastating firepower. Now, seeing the machine up close on the ground, he understood why his tactics had failed. The P-47 wasn't designed for the kind of air combat German pilots trained for. It wasn't built to dogfight in turning engagements where skill and agility determined outcomes. It was built to dominate through position, energy, and firepower. It was built for pilots who understood that modern air combat had evolved beyond individual duels into team engagements where coordination and mutual support determined success. Most critically, it was built by a nation with industrial capacity to produce thousands of them, ensuring that numerical superiority eventually overwhelmed any tactical advantages German pilots might achieve through superior training or individual skill. After the exhibition, Beetle transferred to operational evaluation with the Wunderzirkus Rosarius, a specialized Luftwaffe unit commanded by Flugkapitän Ted Rosarius. This organization toured frontline fighter bases across Germany and occupied territories, providing Luftwaffe pilots with close-up familiarization of enemy aircraft they would encounter in combat. The unit operated an eclectic collection of captured Allied types, including multiple American fighters, British Spitfires and Tempests, and Soviet designs from the Eastern Front. The demonstrations proved invaluable for fighter pilots who had never seen enemy aircraft except at high speed in day combat. Rosarius and his pilots flew the captured types through typical maneuvers, showing how they looked from various angles, demonstrating their performance characteristics, explaining their strengths and weaknesses. Luftwaffe pilots stood on airfield ramps watching captured P-47 seconds fly overhead, noting the distinctive sound of the Pratt & Whitney engine, observing the massive size, studying the profile for recognition purposes. But these demonstrations also demoralized many pilots who understood the strategic implications. Seeing multiple captured American fighters lined up on German airfields made the scale of Allied production undeniable. Each captured aircraft represented thousands more flying from bases in England. Each demonstration flight showed capabilities that German fighters struggled to match. Each technical briefing revealed design sophistication that German industry was failing to replicate. Hans-Werner Lerche flew numerous demonstration missions with the Wunderzirkus Rosarius throughout spring and summer 1944. He would later write in his memoir that watching German fighter pilots' reactions to the captured P-47 was often more enlightening than the technical data gathered at Rechlin. Young pilots, fresh from training, looked at the massive American fighter with apprehension, understanding they would soon face these machines in combat with inadequate preparation and obsolescent equipment. Veteran pilots with dozens of missions looked at the Thunderbolt with resignation, recognizing that individual skill couldn't compensate for systemic disadvantages in aircraft performance and numerical inferiority. May 29, 1944. A second P-47 Thunderbolt fell into German hands when Second Lieutenant Lloyd Hathcock of the 301st Fighter Squadron became disoriented during a mission and mistakenly landed in Rome, where German forces still controlled the airfield. This particular P-47, serial number 42-75971, had previously been the personal mount of 8 Victory Ace George Novotny of the 317th Fighter Squadron. German forces quickly secured the aircraft and transported it to Rechlin for evaluation. This second captured Thunderbolt, coded T9+LK in Luftwaffe markings, provided fresh opportunities for detailed examination. Engineers compared it to Beetle, looking for evolutionary changes between production blocks that might indicate vulnerabilities to exploit or improvements requiring new German countermeasures. They tested various ammunition types against P-47 structure to determine optimal attack profiles. They evaluated the effectiveness of different German cannon calibers against American armor and self-sealing fuel tanks. What emerged from these tests confirmed earlier assessments. The P-47 was extraordinarily resistant to battle damage. The radial engine could sustain multiple hits and continue operating. The airframe absorbed 20mm cannon shells that would have shredded lighter aircraft. The self-sealing fuel tanks prevented fires from small-caliber machine gun hits. The armor plate around the cockpit defeated most attacks except direct hits from 30mm cannon at close range. German pilots needed approximately 20 hits from 20mm cannon shells to reliably destroy a P-47, assuming hits were distributed across vulnerable systems rather than concentrated in non-critical areas. Given that average pilot accuracy against evasive targets at combat ranges ran approximately 2%, bringing down a single Thunderbolt required firing approximately 1,000 rounds of 20mm ammunition. Early model Focke-Wulf Fw-190 fighters carried only 500 rounds total of 20mm ammunition distributed across 2 or 4 cannons. Even with upgraded armament, German fighters lacked sufficient ammunition for multiple attack runs against the rugged American fighters. Meanwhile, the P-47's 850 caliber machine guns threw a combined total of over 6,000 rounds per minute into the surrounding airspace when all weapons fired simultaneously. The 50 caliber Browning M2 machine gun delivered 3 times the kinetic energy of German 7.92mm rounds and comparable energy to German 13mm heavy machine guns. Each gun carried between 267 and 425 rounds, depending on position and mission requirements, providing sustained firepower throughout extended combat. The Americans had solved the fighter armament problem through brute force, rather than technical sophistication. German fighters carried fewer, more powerful cannon that required precise marksmanship to achieve hits. American fighters carried many machine guns that allowed pilots to hose target areas with volume of fire, accepting lower hit probability per round by dramatically increasing rounds fired. Against bomber formations or ground targets, the American approach proved devastatingly effective. July 1944. Intelligence reports reaching Rechlin painted an increasingly desperate picture of the air war over Germany. Allied escort fighters, primarily P-47 Thunderbolts and increasingly P-51 Mustangs, maintained continuous presence over German airspace from the English Channel to Berlin and beyond. Luftwaffe fighter units suffered catastrophic losses attempting to intercept bomber formations protected by hundreds of American escorts. Average life expectancy for German fighter pilots had dropped to weeks rather than months. Pilot quality declined as experienced aces were killed and replaced by hastily trained novices with barely 100 hours of flight time. The strategic situation had deteriorated beyond recovery. American bomber streams flew daily missions with 1,000 or more heavy bombers, each protected by 3 to 500 escort fighters. German fighter forces could muster perhaps 200 to 300 interceptors for major defensive efforts, and these fighters faced overwhelming odds against numerically superior opponents, flying superior aircraft from altitude advantage. The mathematics of attrition guaranteed German defeat, regardless of individual combat outcomes. Even successful German attacks on bomber formations achieved Pyrrhic victories. Shooting down 10 B-17 seconds while losing 15 Fw-190s and Bf-109s represented a tactical success that translated to strategic failure. The Americans could replace 10 lost bombers within a week. Germany couldn't replace 15 lost fighters in a month. The Americans could train replacement crews faster than Germans could kill them. Germany was losing irreplaceable veteran pilots faster than training programs could produce minimally competent replacements. The captured P-47 seconds at Rechlin had taught German engineers and pilots everything they needed to know about the Thunderbolt as a weapons system. They understood its strengths, including exceptional high-altitude performance and devastating firepower. They knew its weaknesses, including poor low-altitude maneuverability and mediocre climb rate. They had documented its capabilities in terms of speed, range, and service ceiling. They had developed tactics that, when executed properly by skilled pilots, could achieve favorable outcomes in individual engagements. But this knowledge couldn't change the fundamental arithmetic of industrial production that determined strategic outcomes. For every German pilot who learned to attack P-47 seconds, effectively through training at Rechlin or through combat experience, the Americans trained 10 new fighter pilots. For every Thunderbolt shot down over Germany through superior German tactics, American factories built 5 more fighters. For every successful interception that disrupted a bombing raid, a dozen more raids flew the next week with even larger formations. The production statistics told a story of overwhelming material advantage that German intelligence understood but could do nothing to counter. By war's end, in May 1945, American factories had produced 15,683 P-47 Thunderbolts across all variants. Peak production in 1944 saw Republic Aviation completing approximately 362 fighters per month, more than 12 per day from a single manufacturing facility. This production rate exceeded total German fighter output across all manufacturers and all types. Germany never built 15,000 single-engine fighters of any type during the entire war. The Focke-Wulf Focke-190, produced from 1941 through 1945, totaled approximately 20,000 aircraft across all variants, including fighter bombers and ground attack versions. But this production occurred over 4 years from multiple factories while under constant Allied bombing. The Americans built nearly as many P-47 seconds in 2 years from peacetime factories operating without enemy interference. The captured P-47 seconds revealed American manufacturing methods that explained these impossible production rates. German engineers studied the modular construction that allowed subassemblies built at different factories to fit together perfectly during final assembly. They examined the standardized components sourced from hundreds of subcontractors nationwide. They analyzed the simplified assembly sequences that allowed semi-skilled workers to build complex fighters in a fraction of the time experienced German craftsmen required. Every design decision in the P-47 reflected a philosophy of mass production over artisanal quality. Standardized fasteners throughout the aircraft reduced inventory requirements. Straight panels with minimal compound curves simplified forming operations. Modular subassemblies allowed parallel and construction of components that came together in final assembly with minimal fitting. This approach enabled Republic's factories to complete one P-47 approximately every hour at peak production rates. German factories using traditional aircraft construction methods with custom-fitted components required weeks to build a single fighter. Even with streamlined processes and slave labor, German production rates measured individual aircraft per factory per week. American production rates measured individual aircraft per hour from single assembly lines. The productivity difference of 50 to 1 or greater made German industrial resistance futile against American material superiority. August 1944. Reports from Normandy following the Allied invasion showed P-47 Thunderbolts had transitioned from high-altitude escort fighters to devastating ground attack aircraft. The 850 caliber machine guns that proved effective against German fighters proved even more devastating against ground targets. P-47 seconds destroyed German armor, trucks, trains, and troop concentrations with withering fire from their wing-mounted machine guns. They carried rockets and bombs for hardened targets. They flew close air support missions that disrupted German counterattacks and allowed Allied ground forces to advance rapidly through France. The versatility demonstrated American design philosophy that prioritized adaptability over specialization. German fighters were optimized for specific roles. The Fw-190A series focused on air-to-air combat. The Fw-190F and G series specialized in ground attack. Separate aircraft types filled different missions. The Americans built one basic fighter that excelled at multiple missions through standardized weapons, mounting points, and robust construction that could absorb ground fire. Between D-Day on June 6, 1944, and victory in Europe on May 8, 1945, P-47 Thunderbolts destroyed 86,000 railroad cars, 9,000 locomotives, 6,000 armored fighting vehicles, and 68,000 trucks, according to pilot claims compiled after the war. These numbers, while certainly inflated through overclaiming common to all air forces, indicated the scale of destruction that hundreds of heavily armed fighters could inflict on ground targets when operating with near-complete air superiority. German ground forces came to fear the distinctive sound of the Pratt & Whitney radial engine and the sight of bubble canopy P-47 seconds circling overhead. The fighters attacked with impunity during daylight hours, forcing German forces to move only at night and hide during day. Supply convoys took days to cover distances that should have required hours. Reinforcements arrived late to battlefields after losses to air attack. The systematic interdiction campaign strangled German logistics and mobility, contributing as much to Allied victory as the heavy bomber strategic campaign against German industry. October 1944. By this point in the war, the Luftwaffe had tested and evaluated 3 captured P-47 Thunderbolts at Rechlin. Multiple German pilots had flown the type extensively. Technical reports filled filing cabinets with detailed data about every system and every performance characteristic. Tactical bulletins distributed to fighter units explained optimal attack approaches and known weaknesses. Training films showed the P-47's flight from various angles for recognition purposes. Yet this accumulated knowledge provided no practical advantage to German pilots still flying Fw-190s and Bf-109s against hundreds of Thunderbolts escorting American bomber formations. Understanding the enemy's capabilities didn't eliminate those capabilities or provide countermeasures when the fundamental problem was industrial capacity rather than tactical doctrine. Hans-Werner Lerche, reflecting on his experiences decades after the war, wrote that the captured P-47 seconds taught him more about American industrial civilization than about American aviation technology. The Thunderbolt wasn't the best fighter aircraft of World War II by any single performance metric. The Spitfire turned better. The Fw-190 rolled faster. The P-51 Mustang flew farther. The Messerschmitt Bf-109 climbed faster at low altitude. But the P-47 represented a complete weapons system designed for mass production, ease of maintenance, pilot survivability, and mission versatility. It embodied American pragmatism that accepted adequate performance across multiple roles, rather than pursuing excellence in narrow specializations. Most critically, it could be built in numbers that overwhelmed any tactical advantages German fighters might possess through superior performance or pilot skill. The defensive firepower that so impressed German test pilots was merely the visible manifestation of deeper American advantages in industrial organization, resource allocation, and economic mobilization. The real secret wasn't the 850 caliber machine guns mounted in the P-47's wings. It was the economic system that could design, manufacture, and deploy 15,683 of these fighters, while simultaneously building 300,000 aircraft of all types, 88,000 tanks, 41 billion rounds of ammunition, and everything else needed to fight a global war on multiple fronts across several continents and 2 major oceans. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.